Let's proceed with determining the derivatives of the following functions. The functions is in the form of e and ln, where the formulas can be referred from here. Differentiations of e power of ax, the a will be bring forward while maintaining the functions. As for ln x, after derivations, you obtain 1 per x. Back to the example here. For function y equals to 3e power 5x, the phi is being brought forward and the functions is maintained. That gives you 15e power of 5x. As for these functions, it can be rewritten in the form of e power negative 3 theta. Derivations, it will bring forward the negative 3 and the e power negative 3 theta will remain. With that, negative 6 per 3 e 3 theta is obtained. For y equals to 6 ln 2x, the constant number will remain. The ln 2x, it will be converted into 1 per x. This is regardless the factors of 2 within the ln. As based on the formulas, ln ax will give you 1 per x. The constant a here will disappear after the derivations. As for these examples, the equations given is y equals to 3x power 4 minus 2x squared plus 5x minus 2. The questions asks us to determine the gradient at point 0, negative 2 and point 1, 4. The gradient of the curve will be represented by the differentiations of the functions. With that, we just need to differentiate the functions and substitute the relevant numbers into the equation. First, we differentiate the functions. The 4 is being brought forward and the power is to be minus by 1 for the first term. For the second term, the power of 2 is being brought forward and the power is to be minus by 1. And since go to the third term, and the last term is a constant. After differentiations, it will become 0. Rewrite the equations, give you this. Now we need to determine the gradient at these 2 points. For the point here, you know that the x is equals to 0 and equals to 1. To determine the gradient at point 0, negative 2, you just need to substitute 0 into the equation here. This will give you dy dx equals to 5. And to determine the gradient at point 1, 4, substitute y into the equations, you will obtain 13. This will be the gradient at the 2 points here. Next, you are asked to determine the coordinate of the point on the graph having the functions of y equals to 3x squared minus 7x plus 2. It is given that the gradient is equals to negative 1. Again, you know the gradient is represented by dy dx. Differentiate the functions, you get 6x minus 7. It is given that dy dx is equals to negative 1. Substitute negative 1 into the equations. There is only one unknown here, and you will get x equals to 1. Now you know that when x is equals to 1, the gradient will be equals to negative 1. However, the questions asks us to determine x point on the graph. That means we need to determine xy also. With that, you will adopt the function here, substitute the 1 in the x into the function. Solve the functions, you get y equals to -2. Based on the answer here, you know that the gradient of the curve will be equals to 1 at the point 1, -2.